everyone. Welcome to MLAS 800, Introduction to Prompt Engineering for Large Language Models. And we're going to be focused on some of the basics of prompt engineering and what is prompt engineering and why are we even talking about prompt engineering in this course. And well, we need to take a step back. So we've up to this point we've gone through and we've started to get a better understanding of what large language models are. We've done two labs up to this point, focused on a little bit of Python, but also spinning up our own large language model. And now, as part of that, the next step is for us to kind of understand how to interact with this. So the machine learning part of this course, of course, is the neural network, we're honing in on the machine learning part through our understanding of large language models and incorporating them at multiple levels, not just an understanding of them and their interactions, but us architecturally working with large language models and understanding them and how they operate within the machine learning arena, and contribute to artificial intelligence at large. So the other part of that is the autonomous systems part, of course. We spun a large language model up, and we made it interactive and ran it as a service within our Google Colab environment. And now that we've got a large language model up and running, and we have a framework for doing so, we can actually integrate multiple different large language models. And we'll do that. We're going to play with different large language models, and then I'll start to explore multimodal models, because these truly are autonomous systems. And that's really the intent of this course, is machine learning and autonomous systems, not just individual machine learning algorithms. So we'll do a little bit of a lecture this week, and then we'll do a lab here following up with that, and get back into doing a little bit of coding with our large language model. But as part of that, and interacting with that is through prompts. And so you probably heard a lot about, well, prompt engineering and what is prompt engineering. And I think high level, we just think, oh, well, that's conversational, having a conversation with the large language model through a prompt. And yes, that's true, and it's not so simple, because if the way I look at prompt engineering, it is exactly like having a conversation with another person. And think of prompt engineering as almost like um, this the same through the same lens. If I am talking to a person, I'm actually going through literally a prompt engineering exercise, right? I come up and I say, hey, how's your day? And then that's a prompt to a person, right? And how was work? And then the person will go through the process of explaining how work was and classifying whether it was good or it's bad, or going through a historical chronology. And as a good prompt engineer, you will do things to reinforce that conversation, and topics within that conversation, to elicit information from the the learning machine that's in front of you, whether that be a person or whether that be a large language model. So it's a very interesting kind of lens to view this through. But let's go ahead and get right into large language models, and what is prompt engineering and what does that even mean for us in this context. So we already know what, just to kind of recap, large language model. It's a really large AI system. We've gone through different architectures and different versions. We've also talked about different frameworks, whether it be Mistral, Stable LM, Llama, different versions of Llama. So those are all available. When we talk about different language models, there's different types of language models and their specificity, whether it's zero-shot learning, whether it's domain specificity, whether it's language representation, whether it's and or whether it is multimodality or whether it is multimodal. That's the newer form of large language models that exist today. And so zero shot learning has to do with the ability of a model to be able to take in vast amounts of information and then be able to, without any additional training data, be able to perform a task in another domain that it is not trained to do. So think of it as I'm asking a large language model to do certain tasks or perform certain activities in, let's say, cooking, right? I wanted to create some recipes for me, but then I want to turn around and say, hey, I want to now do something as it relates to a repair of a vehicle, right? That would be the concept of zero shot learning. Like if my model wasn't trained on, let's say, food recipes, but it was built and trained up on being able to do auto repair, then what ends up happening is we can measure that model's capability to do what's called zero shot learning. Now, the, we do have next up domain specificity, which is we can train or sensitize a model to be specific to a particular domain so that it's better than other models at a domain. So think of it as something similar to, like, maybe if I was training a model up for doing legal precedents, right? Like an attorney type of large language model, that would be a domain specific type of large language model. Now, you also have language representation, which is just like it sounds, and that you have large language models that are better positioned for being more language focused, more conversational. And then multimodal is the latest one where I have large language models that can take in and output information in different formats. And that can be, for example, it can, let's say, ingest data that is a sound file, not just textual language, but a language model that can incorporate, I'm sorry, an LLM that can incorporate video data, vision data, picture data, sound data, not just textual representation of data. So that's what we mean by multimodal. Um, so when we talk about these, the next level is how do I interact, which is prompt engineering. So I have prompt, and that's what we're going to talk about here in more detail. It's about the process of being able to design and optimize a prompt to guide a model's output. And when you look at how this has evolved over time, when GPTs came out years and years ago, we're talking about um, man, 5, 6, 7, 8, 9, 10 years ago. Um, Prompt engineering wasn't even a thing on anybody's radar. But now that they've evolved so progressively fast in the last 3 years, there's just been such an explosion of new ways of thinking and new skills that have to be developed. Prompt engineering was one of them, and by the time GPT-3 came out, prompt engineering, people were getting paid to be prompt engineers and making really good money doing it. But it really wasn't until about GPT-3 came out at 175 billion parameters. And GPT-3, it was a big major milestone. That's when the open AI large language models got to the point where they started to show some usefulness. They really did. And then now we've got GPT-4, GPT Omni, 4 Omni rather. And then of course, we have a lot of other different large language models that are out there. So, what are the basic concepts of prompt engineering? So, there are high level. You've got 7 different big major areas of what we'd say is part of the design pattern as it relates to prompt engineering. So you have different prompting patterns. You have different problem solving patterns. You have different ways that you um, do prompting in terms of their directionality. So that's reverse prompting. You also have the structure of the prompt itself, self improvement, performance, and then there's risk mitigation patterns as well. And so all of these are there's so many different styles of prompting. We won't be able to cover. This isn't a prompt engineering course. This is not meant to be, but prompt engineering has turned into its own such a wide body of work that it could be its own course. It could almost be its own degree. That's how explosive prompt engineering has gotten into, or I should say, how much it has grown over the last few years. So we'll do we'll give it some time. We'll spend some time this week. We'll spend some time next week on prompt engineering, and then we'll move on to other aspects of the autonomous systems architecture that I want to get to. But for now, this is we'll do a high level run through of prompt engineering. So, what are the major techniques of prompt engineering? So, there's quite a few. I showed you a few, like zero shot, and then there's called few shot, and then there's called fine tuning, and there are a lot of others though. There's chain of thought, chain of symbol. There's generated knowledge, least to most, self consistency, self refined, complexity based. There's typically, and there's growing. There's at last I counted, there's close to 30 different prompting techniques. And so again, back to my earlier comment, it's a lot more complicated. And I will highlight these as we move along in our lab. So our lab this week, I'm gonna highlight some of these and go. This is a through our large language model that we have spun up. I'll highlight what like a chain of thought looks like or a chain of symbol looks like, and so I'll show you what that ends up doing versus just kind of just having a general conversation with your large language model. Okay. So you might be asking, well, what are the applications for prompt engineering? Well, there's quite a bit. Prompt engineering. So some of this is also about procedurally standardizing what the large language model's output is going to be. A prompt engineer isn't just about having a conversation with a large language model for conversation's sake. A prompt engineer is also going to be focused on if I feed it, so remember we've got APIs, these little connectors into our large language model that allow us to automatically feed in data and automatically receive data from our large language model through these APIs. So the real world implication of a prompt engineer is to standardize, because remember, these are stochastic machines. These are, well, I shouldn't say quite stochastic. These are large. Let me just say, let me stick to the very specific. These are neural networks. These are large neural networks. And these large neural networks, when they're trained, have amassed up a lot of logic and intellectual property as it relates to what it has been trained on. And so it is as a learning machine, a prompt engineer that is going to be able to standardize the incoming prompts as well as what prompts go into making a consistent output from that large language model. And that's really that is a big part of the real world application of what a prompt engineer or a prompt engineering process does is it standardizes both the input and the output, or I should say standardizes the input and interaction with the large language model to standardize an output from the large language model. So there's some challenges with this, of course. So some common issues is, of course, biases. This is related back to the training data. How does a large language model develop its bias? Well, its biases can come in from the training data that has been fed. So, for example, if I feed it really bad data, I'm gonna get bad biased amplified data, which brings up some problems for like ethical uses, misuse. So if I can incept the large language model with bad data in certain areas, I can make it seem like it's intelligent overall, but then give bad data in smaller areas, and that could be critically dangerous. Um, um, so there's you can imagine what one could do. For example, if I created a large language model for military purposes, and then that large language model was fed tiny inflections of bad strategic data about how to move an army, let's say, or how to maneuver in courses of fire, let's say. Well, that could potentially be problematic if because here's the thing: if I make it seem like the whole large language model is intact at a high level, right? But then I feed it very specific bad data in critical areas. I can weaken the large language model and make it. I can weaken it in really critical ways. So that's something that has to be thought through, and we have to be very careful. And that could be potential misuse for the large language models. Same thing for social media, like or usage in the broad knowledge of science, or medical, right? I could feed it bad medical data, and then it could be making bad medical outputs. So there are things that we have to be very careful with, and of course that means that things have to be grounded in logic and in scientific discovery and in facts. Things have to be equivalently fact-based, data-based research. And what I mean by that is the database and the data that is supplied to large language models have to be factually relevant. They have to be grounded in actual science and actual facts, and then of course they need to be continually tested. So that there are some challenges that are still existing there, in this, and we can highlight that through prompt engineering. Okay, so what are the best practices as it relates to effective prompt engineering? So you've got to have there's three big, I should say four. We've talked about one of those, which is understanding the techniques. But then one is the prompt components. High level, there's the context, the instruction, the input data, the output indicator. I've talked a little bit about all those, minus the content and instruction. And so so as an example, there's on our upper left hand corner here, context is, what is it that you're trying to do? And in this case, let's say you're analyzing the sentiment of social media content. Well, that's critically important in this case. If you are an expert and you are doing sentiment analysis, that's the context. Well, and then what you want to do is provide that context to the prompt, right? So when I'm chatting with OpenAI, I almost always give it a prompt for what is it? Here is the mode that I want it to go into, right? I'm like, okay, I want to be focused on military strategy. Great. Well, I'll give it a prompt right up front. Please provide a frame of reference for military strategy. Right. Great. And that's the first thing that I'll do. And then next up, you want to give a classification. You want to give it instructions, right? Because what I'm doing in the first is just providing context, and the context sets the domain. This is the high level domain that I'm operating within, and it could be medical. That's another example. And then and if you're going to set a new prompt, you want to start over again to set the large language model up for success by saying, hey, I want to shift our lens to medical diagnostics, and then you kind of narrow the scope down, medical diagnostics as it relates to liver functions, right, or liver within humans. Great, you narrow it down. So there's some things where then at that point you'll give it an instruction set, right? You want to say, hey, within this area, And then if we're using social media, if I go back to the social media context, I can say, hey, here's some text that I just received. Can you classify the text that I received on my social media channel into positive, negative, or neutral? And then that's an instruction. And then the input data, then that data, you provided the data and the prompt, and then the output, of course, is the large language model sentiment, and then it does the analysis. And so some of the best practices are, of course, understanding the model. So understanding the model that you worked with is critically important, because if you're doing sentiment, as an example, if you're doing sentiment analysis on a large language model that was trained on, let's say, medical diagnoses, then and therapeutics, like, say, it's a medical model, it's a large language model focused on human medicine. Well, having it go through to do sentiment analysis when it wasn't tuned on that isn't really useful, or isn't appropriate. So you have to be very specific on understanding the model's capabilities and how it was tuned. In other words, understanding how the data was pre-trained, and its training data. And then you got to use clear language, use specific language, be very, it's like having again, I look at the best practices down here as these are things that you would do if you were talking to another human being, right? Use clear and specific language, provide examples, right? In other words, if you're having a conversation with someone, provide allegories, provide stories, provide things that create common understanding, create visual explanations, create textual explanations. These are things that just depends on the audience that's in front of you. Explain the content in as much detail as possible, right? Experiment with different formats and styles. So sometimes you have to go, people say, I don't understand what it is that you're talking about. Great. Well, let me try a different route. And then what you'll do is explain it in different ways. So that those are all things that you go through and rinse, wash, and repeat, right? You're going to evaluate the response you get back from the conversation, and then you're going to refine it, because you won't always get the response back that you're looking for. So you'll have to come through and refine that. Okay, so that's high level, and then from a best practices perspective, again, if you think about it as if you're talking to another person, that's really a good lens and frame of reference to be thinking about prompt engineering from. So, what are the future directions? Well, I think the big one of all the future directions, there's a lot of them, but prompt engineering, I think advances in prompt engineering is going to come from not just human to machine interaction. In other words, the prompt engineer to the machine, but it's going to be the machine to machine. That's really where the advances are going to come from, where I have a machine that is prompting another machine. And you've probably seen some YouTube videos of this occurring already. And it's pretty wild, especially with when someone puts ChatGPT for Omni on two iPhones and then have them converse with each other. It's pretty wickedly wild. It's just interesting how good it is. So I do think that there's a lot of research in that area. I mentioned mitigating biases, getting better about not just the ethics, but of course there's always ethical conversations that need to be had with any technology, not just AI. But I think there's going to be a lot of research that's going to be needed on how do I secure the training data that is used. So the future of this, there's going to be a security aspect related to AI and securitizing our own AI assets in the United States, or not even just the United States, but just in corporations. Like if you create a large language model for a corporation, it's not so much the compute engine itself that becomes important. I mean, it is the large language model's compute engine, and the architecture of the large language model itself is important, but the underlying data is critically important. How it was trained become and that's the secret recipe that goes into the cooking, right? That's the base ingredient, and you have to protect the base ingredients that went into the 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 the, the, the into the kitchen, right? So that's the way that I am seeing kind of the future directions in prompt engineering. It's not just in the prompt engineering itself, which is the machine-to-machine piece, but it's also the back-end cybersecurity pieces of that as well. Okay, so last up, let's do a recap, and then we'll get you over to a quick lab so that we can kind of see how this all works real time. So prompt engineering, we went through that crucial skill. We've realized that it's a great, effective part of the autonomous systems, large language model, machine learning framework. And then we've also seen how prompt engineering is used in enhancing the model's utility. Not we've talked about it, but we're gonna see it in action in the lab. And then we also talked around techniques, best practices, and then what the future looks like. So that's it for this lecture. And then next up, we'll have a lab for this week, so we'll head on over there to actually see all this in action. Thank you, and we'll see you over in the lab.